Hello everyone. Yesterday we looked to the basics of solar and also we discussed few terms of moments conforming to solar constant, and then we listed three angles of solar, sun and earth. So we discussed three angles which were the latitude, the declination as well as the hour angle. And today we are going to discuss few other types of angles that are concerned or known with respect to the solar collector. So first is the tilt angle of the solar collector, or you can say a PV module. Okay, we just look at the diagram and then go for explanation. As you can see, the north pole is marked. The collector, as you can see, is placed where you can see the equator is shown, the local horizontal, and the phi angle, which is our latitude, is shown. Three base marks have been taken: June, equinox, and December. Okay, so phi latitude has been shown. This angle will be equal to that with respect to this phi will be equal to this phi, both represent the latitude because of the basic mathematics. Now the figure is showing a south facing collector on the Earth's surface that is tipped up at an angle equal to the local latitude. Okay, so this is your latitude phi, and this collector has been kept exactly by measuring this same phi. So the latitude, the collector is placed at a latitude of phi. Okay, so with this tilt angle, the collector is parallel to the axis of the Earth. So during an equinox, when I say equinox, it is this condition. Okay, parallel ആയിട്ടാണ് place ചെയ്തിരിക്കുന്നത്. Okay, so the equinox condition വരുമ്പോൾ solar moon, when the sun is directly over the local meridian, the sun's rays will strike the collector at the best possible angle. Okay, so it will be perpendicular to the collector face. So അപ്പോൾ എന്താണ് നമുക്ക് maximum sunlight rays collect ചെയ്യാൻ പറ്റുന്ന രീതിയിൽ. So generally solar moon ആണ് നമ്മൾ important reference point ആയിട്ട് എടുക്കുക for all solar calculations. Where any other times of the year, sun will be a little higher, little low. So for the best tilt angle, it's always good to take during the equinox at solar moon. Now in the northern hemisphere, at latitudes above the Tropic of Cancer, the solar moon occurs when the sun is due south of the observer. നമുക്കറിയാം എല്ലായിടത്തും ഒരേ രീതിയിലല്ല, ഓരോ കൺട്രീസിലും ഓരോ രീതിയിലാണ്. സൗത്ത് ഓഫ് ദ ട്രോപ്പിക് ഓഫ് കാപ്രിക്കോൺ, ന്യൂസിലൻഡിൽ സൺ ഡ്യൂ നോർത്ത് ആയിരിക്കും, ട്രോപ്പിക്സിൽ സൺ ഡ്യൂ നോർത്ത് ആവാം, സൗത്ത് ആവാം, ഡയറക്ട്ലി ഓവർഹെഡ് ആവാം. So on an average, we will be taking that facing a collector towards the equator. Okay, so because most of us in the northern hemisphere, this means you are facing it south. Okay, and tilting up at an angle equal to the local latitude is a good rule of thumb for annual performance. Winter വരുമ്പോൾ almost different ആണ്, പക്ഷെ നമ്മൾ on an average എപ്പോഴും collector വെക്കുക ഇങ്ങനെ രീതിയിലായിരിക്കും. ഇക്വേറ്ററിൽ നിന്ന് വരുന്ന ലാറ്റിറ്റ്യൂഡിന് കറക്റ്റ് ആയിട്ട് ടിൽറ്റ് ചെയ്തിട്ടുള്ള ഒരു ആംഗിളിലായിരിക്കും. Okay. So the altitude angle is the angle between the sun and the local horizon directly beneath the sun. Okay, you can see the representation of the figure that is shown. Angle between the sun and the local horizon directly beneath the sun. So you can see that is why this is marked as alpha. Okay, angle between the sun and the local horizontal, it is taken as altitude angle alpha. Okay, and from the figure, this alpha is going to be 90 degrees minus C. This is 90 degree, and this is alpha, and this is phi. So obviously alpha is going to be 90 minus phi plus this small angle is marked as delta. Okay, so phi is the latitude of the site, and you can see a term that is introduced, that is zenith, and this term means an axis drawn directly overhead at a site. Okay, it means this is going to be above your sun as well. So ഇത് മൊത്തമാണ് 90 degree. അപ്പോൾ ഇത് phiയും ഇത് deltയും alpha ആണെങ്കിൽ your alpha is going to be 90 degree minus phi plus delta. Okay, so altitude angle അങ്ങനെയാണ് നമ്മൾ ഡിഫൈൻ ചെയ്യാം. Now again, for a northern hemisphere, see the south, north, west and east is marked, and from there three angles have been marked. The sun's zenith is represented by the Z, so that is this angle that is represented as zenith. And then you have the altitude angle, which is our alpha, and you're going to declare two more angles, which is the azimuth angle and the represented as theta Z, and another angle known as gamma. So the explanation comes in the next one. The azimuth angle is gamma and the zenith angle is theta Z. So altitude angle we already saw to the vertical angle between the direction of the sun's rays and its projection. Now zenith angle is the vertical angle between the direction of sun rays and the line perpendicular to the horizontal plane through the point. So the theta Z plus alpha is going to be equal to pi by 2. We'll just have a look at the diagram again. So see the theta Z where it is being placed between the zenith and the sun's rays. So that is what has been explained here. Angle between the direction of sun rays and the line perpendicular to the horizontal plane. So theta Z plus alpha gives you pi by 2. See the diagram. Theta Z plus alpha gives you pi by 2. And that is again explained in terms of cos angles. So for horizontal surface we can take that cos theta Z is going to be equal to cos phi, cos delta, cos omega plus sin theta, sin phi. Okay, just remember this expression. We may be using it for small numerical problems. Okay, and omega, as you know, is the hour angle which we learned in the previous class. Now you have one more angle, which is the surface azimuth angle, and it is an angle subtended in the horizontal plane of the normal to the surface on the horizontal plane. So this angle is generally taken positive if the normal is west of south, and it is taken negative in the east of south is in northern hemisphere. Northern hemisphere വെച്ചിട്ടായിരിക്കും നമ്മൾ എല്ലാം പറയുണ്ടാവുക. southern hemisphere വരുമ്പോൾ ഇതിന് നേരെ opposite ആയിരിക്കും. Okay, azimuth angle ഒന്നുകൂടെ കാണിക്കാം. Angle subtended in the horizontal plane of the normal to the surface on the horizontal plane. So you can see this is your azimuth angle, this is your west east portion that is shown, so this is your south and north pole that is shown. So you can see the angle between this and this horizontal projection to the sun rays. Okay, so this much angles are defined with respect to a solar energy, that is today we learned the tilt angle, altitude angle, zenith angle and surface azimuth angle. Okay, and next we have the beam and diffuse radiation. So again for this you need to know basically what is the beam radiation, what is the diffuse radiation and what is the total or global radiation. We first see this and then go for the figure. So the solar radiation that is received from the sun without having been scattered by the atmosphere. So you can see the sun rays are coming directly. Okay, see, that's shown beam, it is coming directly. And diffuse radiation is the solar radiation received from the sun after its direction has been changed by scattered by the atmosphere. So you can see that clouds hitting the cloud, it gets scattered. So that is known as a diffuse radiation. And the total of global radiation will be the sum of both of them on a surface. So let's just differentiate between the solar beam radiation and the diffuse radiation. Beam means directly without any loss, and this is after some losses because it is getting scattered. And this is high intensity because it is coming directly, but this will be low intensity as it is absorbed and scattered, partly by dust, moisture, etc. And this hardly reaches the Earth's surface, and the pure beam radiation exists above the atmospheric layers of Earth. Okay, and in this case, all the radiation reaching the Earth's surface will be diffuse radiation. Now, for beam radiation, the bandwidth is constant, but for diffuse radiation, the bandwidth is lower since ultraviolet rays and infrared rays are absorbed by the ozone layer as well as CO2 once it enters the Earth's atmosphere. And you have two types of meters that are used for measuring them. So you have a pyrheliometer that is used for measuring the solar beam radiation, and you have a pyranometer which is used for measuring the diffuse radiation as well as the total. Total means the sum of both the radiations. So a typically daily solar radiation, which means both total and diffuse, please see the diagram, measured on a clear day as well as cloudy day issue. Okay, clear day is when you have the solid lines, and the cloudy day is the hashed lines. It can be seen that on a clear day, the radiation varies smoothly from low at sunrise to high at the noon, and then gradually drops down to low by sunset. Okay, for the continuous lines, solid lines. So cloudy day, the radiation pattern is disturbed due to varying sunlight through the clouds. അപ്പോൾ അതുകൊണ്ടാണ് നമ്മൾ ഡോട്ടഡ് ലൈൻസ് ആയിട്ട് ആ ഒരു വേരിയേഷൻസ് എക്സാക്ട് പാറ്റേൺ പോലെ കാണാൻ പറ്റും. Okay. So next is we are going for the measurement of solar radiation. So as I said, നമ്മൾ already differential 2 meters കേട്ടു, per heliometer and per nanometer. Just in the introduction മാത്രമേ പറയാം, and in the next class we will learn what is this meters. So this is basically used to measure the solar radiation so that we can find out the useful energy that is transferred, and the instruments measure the sunshine hours and the direct and diffuse solar radiation. So 3 types of basic instruments you have: sunshine recorder, per heliometer and per nanometer. So as mentioned, per heliometer is for the beam radiation, direct radiation, and per nanometer is for the diffuse radiation. Thank you.